Since the inception of the information age, humanity has grappled with a profound question. Are we alone in the universe? This inquiry has fueled speculation about the existence of intelligent life beyond our solar system. While some scientists assert that contact with extraterrestrial beings is inevitable, others remain skeptical, demanding further evidence. In recent years, the discovery of an interstellar visitor named Oumuamua has stirred the debate. Discovered in 2017, this comet marks the first known object from another star to journey into our solar system. While many scientists regard Oumuamua as a typical comet traversing our celestial neighborhood, others speculate that its peculiar characteristics could suggest an artificial origin, possibly indicating it to be an alien probe. In today's video, let's dig deeper into the mystery of Oumuamua and why some scientists believe it may be an alien spaceship. The enigmatic interstellar object known as Oumuamua was serendipitously discovered in October 2017 by Robert Warwick, a postdoctoral researcher at the University of Hawaii's Institute for Astronomy. While conducting scans of the skies above Maui for approaching asteroids, Warwick initially believed he had found a typical celestial body. However, upon closer examination, it became apparent that the object's orbit defied conventional understanding. Through meticulous calculations, astronomers determined that its trajectory was consistent with an origin beyond our solar system. This revelation came as a remarkable surprise, as the astronomical community had long awaited such an interstellar visitor. Before Oumuamua's appearance, no known object from another star had traversed our cosmic neighborhood. Given its discovery from a facility in Hawaii, it was decided that the object would be bestowed with a Hawaiian name. After deliberation on its significance and manner of discovery, the name Oumuamua was chosen. Translated, the name signifies scout or messenger from a distant place, encapsulating the object's pioneering nature. One of Oumuamua's most intriguing attributes is its unusual shape, likened to that of a cigar floating through the vast expanse of space. Although it passed too far from Earth to be discerned as more than a mere speck, even through powerful telescopes, variations in its brightness indicated a distinctly elongated form. Oumuamua's elongated shape is estimated to be at least 7 times longer than it is wide, with dimensions roughly measuring 3,000 feet by 400 feet. Despite initial expectations, the object is relatively small. As it journeys through space, Oumuamua exhibits a tumbling motion, completing one full rotation approximately every 8 hours. While numerous realistic depictions of the object exist, astronomers have yet to confirm its precise appearance up close. Furthermore, Oumuamua is believed to possess a reddish surface, a characteristic often associated with comets composed of ice and rock. However, this attribute remains unconfirmed. Its reddish hue aligns with the coloration observed in other comets. Following its passage near the Sun, Oumuamua experienced an acceleration in its speed, likely due to the outgassing of frozen materials from its surface, a common feature among comets. Despite this, observations conducted by NASA's Spitzer Space Telescope failed to detect evidence of a comet-like tail composed of gas and dust, leaving scientists puzzled by this discrepancy. Oumuamua embarked on a high-speed journey past the Sun, hurtling through space at an astonishing velocity of 196,000 miles per hour. Its trajectory indicates that it had been roaming the Milky Way, untethered to any star system, for hundreds of millions of years before making its entrance into our cosmic neighborhood. While the existence of such interstellar objects had been theorized for decades, Oumuamua marked the first instance where one could be closely observed. Immediately following its discovery, telescopes worldwide, including ESO's Very Large Telescope in Chile, began meticulously measuring and observing Oumuamua's path, orbit, brightness, and color. By combining images captured by the ESO telescope using 4 different filters with data from other large telescopes, astronomers made intriguing discoveries about Oumuamua's characteristics. Notably, Oumuamua exhibits significant variations in brightness, changing by a factor of 10 as it rotates on its axis every 7.3 hours. This phenomenon is unprecedented among known comets or asteroids in our solar system, highlighting the unique nature of this interstellar visitor. Furthermore, the object's reddish hue suggests a composition similar to other inert objects in the outer solar system, devoid of ice or water. Instead, Oumuamua is believed to be densely packed with rock and possibly metals, its surface reddened over eons by the effects of cosmic ray irradiation. As massive telescopes continued to track Oumuamua's journey, it gradually receded from our planet, its luminosity fading into the vastness of space. By 2019, Oumuamua was observed traveling at a relative speed of 85,700 miles per hour in relation to the Sun. Its outbound trajectory took it approximately 20 degrees above the plane of the planets orbiting the Sun. Passing the orbit of Mars first, followed by a journey beyond Saturn's orbit, Oumuamua bid farewell to our solar system, setting its sights on its next destination in the constellation Pegasus. Orbital calculations tracing Oumuamua's path reveal that it originated from the direction of Vega, a prominent star in the northern constellation of Lyra. However, Oumuamua's extended journey over hundreds of thousands of years means that Vega was not in the same position it occupies today when the interstellar object passed through its vicinity approximately 300,000 years ago. Further investigation into Oumuamua's trajectory suggests that it could have originated from a small red star known as HIP 3757 roughly a million years ago, although this remains speculative and awaits confirmation. Astronomers speculate that interstellar objects akin to Oumuamua traverse the inner solar system approximately once per year. However, these objects are exceedingly faint and challenging to detect, making them elusive until recent advancements in observational technology. With the deployment of massive survey telescopes worldwide, astronomers now have a heightened chance of identifying such elusive interstellar visitors. Recent research proposes that Oumuamua's peculiar shape may have been influenced by its origin from a system harboring a dense, central star. This hypothesis is rooted in the notion that dense stars possess sufficient gravitational pull to obliterate passing worlds without incinerating them entirely. Plotting the trajectories of similar objects suggests that if any of these entities venture within approximately 220,000 miles of their host star, they would undergo tidal disruption, resulting in their elongation and eventual shredding by the star's gravitational forces. Depending on the composition of the fragmented parent world, some remnants may assume the elongated form observed in Oumuamua. Oumuamua's peculiar characteristics have fueled speculation, with some likening its appearance to that of a spacecraft from another star system, swiftly passing through our own before vanishing into the cosmic abyss. Intrigued by this notion, astronomers, including researchers at the Search for Extraterrestrial Intelligence, SETI, conducted two separate searches for potential technological signals emanating from the object, yet their efforts yielded no conclusive findings. One prominent theory, posited by Avi Loeb of the Harvard-Smithsonian Center for Astrophysics, suggests that Oumuamua could be an advanced piece of alien technology employing a light sail propulsion method. This theoretical propulsion system utilizes photons from the Sun to propel the craft forward. Loeb's rationale stems from the absence of observable changes in Oumuamua's rotation period, which would typically occur due to outgassing if it were a comet. He proposes that Oumuamua may be a relic of advanced extraterrestrial technology, a defunct piece of spacefaring equipment inadvertently drifting into our cosmic neighborhood. Alternatively, it could be an exploratory vessel dispatched to investigate our corner of the universe. While Loeb's hypotheses remain contentious among the scientific community, he advocates for the inclusion of such speculative possibilities in rational inquiry, arguing that dismissing the notion of extraterrestrial origins prematurely stifles potentially fruitful avenues of investigation. Importantly, Loeb emphasizes that he does not assert Oumuamua definitively as of alien origin, but rather encourages open-minded consideration within the scientific discourse. Presently, concrete evidence linking Oumuamua to an advanced alien civilization remains elusive, with only notable theories offering potential explanations for its enigmatic nature. The scarcity of data relating to the object complicates efforts to decode its true origins definitively. After the sighting of Oumuamua, researchers are eager to detect similar interstellar objects, believing that there could be trillions of such entities drifting through the Milky Way. The study of these elusive objects holds the potential to shed light on long-standing mysteries of the universe, including the existence of life beyond our solar system. The prospect of frequent detections of these interstellar visitors may not be far off, with the impending operationalization of the Large Synoptic Survey Telescope in Chile. This advanced instrument is poised to significantly enhance our ability to observe and study celestial phenomena, including interstellar objects.